In this video, we're going to talk about solving inequalities instead of equations. And once we solve them, then we're going to look at their number line graphs and how to write their answers in something called interval notation. When you have an equation like x plus 2 is equal to 5, and you subtract 2 from both sides, you end up with x is 3. That's the solution because it's the only real number that, if plugged in for x, makes a true statement. An inequality has one of the inequality symbols. Let's say it has a greater than symbol. And by the way, the symbols are greater than, less than, greater than or equal to, less than or equal to. There's also a not equal to sign, but we're not going to be using that one. All right, this says that the solution will be any number that, if you add to 2, is greater than 5. You solve the inequalities basically the same way you solve the equations. There is one exception that we'll talk about in a few minutes, but I will subtract 2 from both sides. X is greater than 3. So you can see that there's a strong parallel between the two processes. The difference is there are an infinite number of solutions. X is any real number greater or bigger than 3. So 3.1, 3.5, 7, 14, 2 million, they're all values of x that are greater than 3. Because of the infinite number, we're going to write the answer in, well, we're going to draw a picture of the answer. On a real number line, let's say there's 0. To the left, it goes toward negative infinity. To the right, it goes toward positive infinity, and that little sideways 8 is the symbol for infinity. For x to be greater than 3, you would locate, there's 1, 2, 3. Greater than 3 is this way. To show that it can't be 3, but it is greater than 3, we use the symbol parentheses. Parentheses means strictly greater than 3. So not 3 itself. 3 is not greater than 3. So here's the inequality. Here's what the number line graph looks like. And now the interval. If you've got a number line graph, you have just about got the interval. The interval is from where to where. It would be like if you had a shift to work and you went on at 2 p.m. and you got off at 6 p.m. The interval you worked is from 2 to 6, when you start and when you end. An interval is the leftmost value, 3, comma, the rightmost value, which in this case is positive infinity. Positive infinity always gets a parentheses on it. And in this case, since it was greater than 3 but not equal to 3, it gets a parentheses also. So here is the inequality. Here is the graph. And here's the interval. We're going to talk more about this interval notation and actually more about the graphing. Let's take a look at another example. Suppose I had 2x plus 1 is less than or equal to 4. Well, let's just make it maybe easier. Let's say 5. You would subtract 1 from both sides. So 2x is less than or equal to 4. Divide by 2. Divide by 2. X is less than or equal to 2. That's your inequality answer. How does that graph look any different? Well, you still have to locate 2 on a number line. Less than 2 is going to be this way. And remember, this is negative infinity, this is positive infinity on a number line. The difference is not because it's less than, but because it has equal with it. We don't use a parentheses here. Because it had equal with it, we use a bracket. That tells somebody that x can be less than 2, but it can also be equal to 2. The interval notation is always left to right. So the interval in this case is from negative infinity to 2. Infinities always get parentheses because they don't stop at infinity. They don't contain infinity. But the 2 is included as a solution, and we indicate that with a bracket. So we will talk more about this. There's one other thing that you need to know. When you divide, and it's true for multiplication also, but we won't be doing that, both sides of an inequality by a negative number, the inequality symbol reverses. It only happens when you divide both sides by a negative number. Okay, and we'll see that somewhere in our exercises. All right, the first one. These are just checking to see if you understand the different notations. There's no solutions here, or nothing to solve. It says, graph the set of numbers in the given interval notation, then write the inequality statement. All right, remember, we have 3 formats. We have the inequality, we have the graph, and we have the interval. So these first few questions are going to have you, they're going to give you one of those 3 and ask you to find the others. So I have, first of all, the interval, 5 to infinity. That means that on the left will be 5 and on the right will be positive infinity. Well, it can't be this one because this is negative infinity. It can't be this one because this is negative infinity. This is going from, and it's a little hard to read, this is 5 to positive infinity. This is 5 to positive infinity. How do those differ? Once again, it's a little tiny to see. It won't be so hard when you're doing your homework. There's a bracket, there's a parentheses. Our interval had a bracket, so it is this choice. That's the right answer. Now, write an inequality. The inequality always starts with the variable x. Now, because it's going to the right, it's going to be greater than. Because it has a bracket, it's going to be greater than or equal to, and then here's your number, 5. This one would be simply x is greater than 5. This one greater than or equal to. All right, you will find these symbols in your tool palette. Let's look at number 2. You're given negative infinity, comma, negative 1. That's the interval. So on the left is negative infinity, and on the right it's negative 1. So it can't be that one. It could be this one because we have negative infinity here. It could be this one because we have negative infinity, and it can't be that one. So negative infinity to negative 1. Negative infinity to negative 1. How do they differ? Bracket, parentheses. Well, we have parentheses, so it's choice C. Now, write it as an inequality. We start with x. Because it goes to the left, it's getting smaller, it's going to be a less than. Because it has parentheses, it's going to just be a less than. If it had been bracket, it would be less than or equal to. Less than negative 1. There's my inequality. All right, this next one starts with the inequality. X is less than or equal to negative 1. All right, that means it's going to be smaller than negative 1, means it's going to go to the left. So it can't be this one and it can't be this one. Both of these go to the left toward, yes, they have a number there, but it's headed toward negative infinity. That was just the last number that they showed on the number line. Not a significant number though. All right, this says less than or equal to. The fact that it has or equal to means that we've got to have the bracket. So it's choice D. This is a picture of all numbers which are either less than -1 or equal to -1. Interval notation, take the two numbers off of the number line. Negative infinity, comma, -1. The infinities always get parentheses. The 1, because it had a bracket, keeps a bracket. Intervals always are read left to right, even if it's pointing the other way. Let's look at number 4. X is less than 1/6. Less than means to the left, so it can't be that one and it can't be that one. Less than 1/6 is to the left. Yes, those both are. They're both headed toward negative infinity, and I'm sorry some of my infinities get kind of crazy looking. Strictly less than, it doesn't say equal to, so just a parentheses. It is choice B. To write that as an interval, I'm going to go from negative infinity to 1/6, always parentheses there, and in this case, parentheses there. You'll get your infinity symbols out of the tool palette also. Let's look at a few more. We're going to graph the inequality on the number line and then write it. Y is greater than or equal to 11. Okay, greater than means to the right. So that one's going the wrong way, that one's going the wrong way. Greater than or equal to, I'm going to be looking for a bracket at 11. Here it is. It's choice B. This is headed toward positive infinity. So as an interval, it will be 11. It's kind of hard to tell that that was 11, comma, infinity. Whoops, sorry. Something's opening. Close it. So sorry. 11 to infinity. Parentheses at infinity. What goes at the 11? Well, it had an equal. It had a bracket. It keeps the bracket. All right, so now that you understand, I hope, the inequality, the number line graph, and the interval, the next lesson will be solving before we graph.